Explain ELI5 by Deadlop. ELI5, how deep drilling, oil, etc. avoids drill twisting on its axis? Wouldn't kilometers long steel drills be akin to licorice? They don't. The pipe absolutely does twist on its axis. On a very long pipe you might put 10 or more rotations into the top before the bit starts to turn at the bottom. But that's okay. As long as the bit is turning and you don't yield, overstress, the pipe, it's fine. There is a huge weight at the bottom, right behind the bit, made of thick wall pipe called drill collars. These make sure the pipe is all in tension so it doesn't want to buckle. One of the major jobs of the driller is to make sure the weight on bit is right so that the pipe doesn't buckle. You always want the drill string to be hanging from the rig. The weight in the bit should only be from the drill collars. All these rotations are part of why you need such tight joints. If the bit sticks, the pipe will temporarily wind up. When the bit releases, all that twist unwinds quickly and can overshoot and actually unscrew a connector if you didn't have the joint torques correct in the first place. Recently drilled a well where we unscrewed 3 times. Twice in one night. We were able to snug back in and prevent having to go fishing, but we ran that driller off pretty quick once we realized he was the problem. The pipe is quite strong in that axis. There will still be some amount of twisting but no permanent deforming. It just means that you need to spin the pipe a few times before the head starts spinning at the bottom of the well. The pipe is selected to be strong enough to withstand these forces. Drilling mud is also key. The actual drill head is only at the bottom. The rest is just pipes that flush away the dirt and carry mechanical movement. The drill pipe twists slightly with resistance from the drilling, but it's been engineered to allow for enough force before getting permanently deformed. It doesn't really matter how long the pipe is, the force in each section is actually the same if you consider friction with the well walls negligible. If you consider friction negligible, we've already finished drilling the well. Certain drilling applications also utilize a piece of downhole equipment called a mud motor. This is essentially a helical rotor inside a tubular. The tool sits at the bottom of the drill string below the collars. Drilling fluid or mud is pumped down the drill string and through the mud motor. The pressure of the drilling fluid spins the rotor inside, thus creating concentric power to spin the drill bit. They are not used in all drilling applications but rather mainly for hard rock formations and directional drilling applications wherein the driller and MWD measure while drilling. Hands will steer the drill string into the zone they want it. These tools are most often used in conjunction with PDC type drill bits. Check out this Wikipedia article https://en.m.wikipedia.org/wiki/mud_motor. Edit, spelling. One big thing is that the fluid recirculating through the well both lubricates, cools, and takes material back up from the drill head. It's called drilling mud, and it's a highly engineered thing. Air mud engineers do very well for themselves. The drill string does twist on its axis. The drill string is akin to licorice. Good analogy, and obviously it can withstand a little more torque than licorice. When you stop drilling on the surface, the drill keeps turning on bottom until the licorice unwinds. The ability of the drill to resist twisting is enhanced by its geometry, a hollow pipe. The same amount of steel formed into a solid rod would be much less stiff, more strain per unit stress, and the difference between the stress in the center, 0, and the stress in the perimeter of a solid rod is much greater than the variation in stress of the pipe. Differential stress will result in failure of the material if the stress is high enough to reach a plasticity point. A rod that's stressed to the point of plastic deformation will snap because the outer portion is twisted and undergoes plastic deformation, while the center is not. For a pipe, even if you were to stress the pipe to the point of plastic deformation, so long as there's sufficient weight on the pipe to keep it from collapsing, you'll still have a pipe, as the stress on the inner portion and the outer portion of the pipe is nearly equal. You'll have a slightly twisted pipe. Imagine stretching an elastic band or a spring until it breaks. Now imagine stretching a chain of 2 until they break. You have to pull further, but you have to pull just as hard. A very long drill isn't any weaker, so it's no more likely to yield or break than a short one. It will just bend stretch further than a short one as long as the rotation force gets to the cutting bit at the bottom. It's doing its job. Does the entire string spin, or do they pump mud down the pipe until the last X feet, and that part is a spinnable turbine that spins just the drill bit? Both for various reasons. If they are drilling straight, then the whole thing spins. If the well needs to be turned to get back on course, then the pipe sits still while the fluid, mud, pushes through the mud motor, turning only the bit. The mud motor has a bend in usually the last 3-4 feet, varies depending on what section of the well. We'll call this one 1.83 degrees. That bend allows the directional driller to turn the pipe just enough to put enough torque to face that bend a certain direction and hold it there while the mud spins a bit, turning the well in the direction it needs to go. After however many feet is needed, then the drive spins and the whole thing spins while drilling until it gets off course again. Depending on drilling method and formations in the ground, most holes will drill in a slight corkscrew fashion. Depending on drilling method and formations in the ground, most holes will drill in a slight corkscrew fashion. Is it just because the sides of the hole are there to support the drill out of plane? TLDR, there's a ton of cash in drilling for oil, so they have solved these peasant problems long ago. How does directional drilling work and how accurately can you steer the drill? There are a few different methods that allow you to drill curved wells. These include bent housing motors and push the bit and point the bit systems. Overall, a correctly designed well can be drilled very accurately. Part of the drilling engineer's job is to plan a well that can accurately be drilled. Some rock formations won't allow tight curvatures in the well's design. The MWD, measure while drilling, tools that form part of your bottom hole assembly will tell you the location of your hole. These send data back to surface in real time using telemetry pressure pulses in the mud system that are decoded at surface. I run down-hole surveys on coring drill operations for mining, and when I look at the hole deviation on holes that run off, it still boggles my mind 10+ at times, and those rods still spin. So, what are the torque values at these extremes? We just finished a well that at bottom we were drilling with 70 kpounds of torque. Okay, ELI5, that question. Why does a long drill twist on its axis, and what does that mean? Totally something outside everyday experience. The best visualization I can give is take a water hose and lay part of it on the ground and then turn the top part in your hand. How many turns at the top does it take before the bottom starts moving? A drill string acts the exact same way downhole. The multiple pipes connected to the drill bit flex at the joints. They have drills that they can guide and go down and sideways.